In this mini lesson, we'll go over a system of equations. System of equations are generally two equations that intersect each other when they're graphed, or you can find them through the process of two other steps, which is called elimination or substitution. But first, let's look at the two equations that we have here, and these two equations are 2x plus 3y is equal to 20, and a negative 2x plus y is equal to 4. Both of these equations are in what we call the standard form. Some of you or all of you might be familiar with the slope-intercept form, and some of you might even be familiar with the point-slope form, but this is called the standard form. So we can find where these two equations intersect each other by three ways: graphing, elimination, or substitution. Let's look at the graphing first. So for those two equations, 2x plus 3y is equal to 20, and a negative 2x plus y is equal to 4. These two lines, or these two equations, cross at or intersect at the point 1, 6. At 1, 6. So over 1 to the right and up 6 is 1, 6. So graphically, if we were solving this by graphing, the answer would be 1, 6. You should also get the same answer if you either use substitution or elimination. So now we'll start with elimination, and we'll find we should get the same answer if we do elimination. So we have 2x plus 3y is equal to 20, and a negative 2x plus y is equal to 4. It is called elimination because you want to eliminate one of the variables by using the additive inverse property. Additive inverse property means that you add the opposite to get 0. So we have to eliminate either the x or the y first to find out what the other is equal to. So if we eliminate the x, we're solving for y. If we eliminate the y, we're solving for x. So if we look at these two equations, we have 2x and we have a negative 2x. This is going to be pretty easy because we already have the opposite for 2x. We have 2x minus 2x here, or a negative 2x. So what we should do is we should add 2x plus a negative 2x to get 0. So let's do that now. So we're going to add, we will add 2x plus a negative 2x. Now, you must add all the other terms also. So let's do it. 2x plus a negative 2x will give us 0. So our x's are gone now, and we're going to be searching for y. So 3y plus 1y, this is 1y. 3y plus 1y is equal to 4y's. And then 20 plus 4 is equal to 24. We are at a one-step equation now, so we have to divide both sides by, because we're multiplying 4 times y, we have to divide both sides by 4. When we divide both sides by 4, we now find what y is equal to. Y is equal to 6. All right, so what we have so far is we have the y, which we'll put here in the ordered pair. We have y is equal to 6. Now remember, in the graph it was 1, 6. So we know the first part is correct when we found y. Now with the y equals 6, you must go back to one of the original equations. It doesn't matter which one, but we'll just choose the first one. Go back to the original equations, and you actually have to substitute now. You have to substitute. So wherever a y is on the first equation, 2x plus 3y equals 20, I'm going to substitute 6. So let's do it now, and we'll get 2x plus 3. The y is now 6, so 3 times 6. And that is going to be equal to 20. And this is how we will find our x. So now, Following the order operations, we'll take 3 and multiply it times 6, and 3 times 6 is 18. Bring our 2x down. 2x plus 18 is equal to 20. Now we're at our two-step equation. We have to undo the 18 by subtracting 18 because it's a positive 18. We subtract 18 from both sides. And now we're left with 2x is equal to 20 minus 18, which is 2. And we divide both sides by 2. We're going to divide both sides by our 2 here. And now we have what x is equal to. X is equal to 2 divided by 2, which is 1. So now we go back to our ordered pair. And x equals 1 and y equals 6. Just as we had in the graph when we seen that these two equations intersected at 1, 6. All right, so this is your final answer when you are using elimination. Let's check and see. Let's go back to the graph to check and see if we have this. We have 1, 6 is where the lines cross. If we go back and look at the graph, we can see that we go over 1 and up 6. So yes, this is correct. All right. So this is a mini lesson on solving system of equations by elimination. And this one was pretty simple because we already had the opposite. We already had the opposite for our additive inverse. So check the next video on the mini lesson when we don't have the opposite and we have to do a little bit of extra work.